So today we're talking about limits again. It's day 2 of limits. And there are some properties that I don't want you to write down. They're on page 819 of your textbook. And we're just going to talk through them. And then you can always refer back to them because I think they're going to make sense for you. Okay. Nope, I don't have. So just if you want to put this on your notes from yesterday, just flip that sheet over and away we go. So like I said, page 819, you don't have to copy these down. But what it's saying is that if we let b and c be real numbers and n be a positive integer, then if we want to find the limit as x goes to c of some constant, we're going to get that constant. Okay? The limit as x goes to c of a constant is a constant. And the limit as x goes to c of x has to be c. Okay? So if we're taking a limit, and the only thing we're taking a limit of is x, and x is going to c, it's got to go to c. That's the identity for limits. Okay? So far so good, they all make sense. Next one, limit as x goes to c of x to some power is the same thing as c to some power. So we're just substituting c in everywhere we see x. And the limit as x goes to c of the nth root of x is going to be the nth root of c. Okay? Provided that n is even and c is bigger than 0, because it's undefined if c is less than 0. Okay? So nothing's earth-shattering here. So let's try it. The first one says, now this is what we can write down so we have some examples to look off of. First one says, find the limit as x goes to 2 of x cubed. So it's going to be 2 to the third, because all we're doing is substituting in 2 everywhere we see x. And we'll get 2 to the third, which is 8. That's it. Okay, that is the limit as x goes to 2 of x cubed. Okay? Just think of what was happening on this graph. X cubed says when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 8. And when x is a negative 1, y is a negative 1. And when x is a negative 2, y is a negative 8. So to follow up with what we were doing yesterday, as we approach 2, x equals 2 from the left, we're approaching 8 for y. And as we approach x equals 2 from the right, we're approaching 8 for y. So it makes sense that it's going to be 8. Okay? Next one, the limit as x goes to 4 of 8x will be 32. We simply substitute 4 in for x and get 32. Now we have a line with a slope of 8 and a y-intercept of 0. So next we want the limit as x goes to 16 of the 4th root of x. So the 4th root of 16, what times itself 4 times gets us 16? 2. And that's legal because c was positive and not, and then our root was even. And the next one, we want the limit as x goes to 3 pi over 4 of the tangent of x. So now we're throwing trig at you. On this one? Exactly. So they would have, if it was 0, we're okay. But if it was a negative, it would be undefined. Okay? And on this one, because we're throwing trig at you, we're just going to say, let's take the tangent of 3 pi over 4. We're substituting 3 pi over 4 in where we see x. And we know it's going to be 1. Is it going to be a positive or a negative 1? Good, because any pi over 4 is a 45. Tangents of 45s are 1s, but we're in the second quadrant at 3 pi over 4, so that's going to be a negative 1. Mm-hmm. Mm-hmm. Uh-huh. Mm-hmm. Yeah, if you just plugged in the number in and found that answer, that's fine. You didn't have to make graphs. They just wanted to show you what the graph was looking like so that you could see the graphical representation. Yeah, no, you didn't have to make a table. Yep. Make sense? Okay. All right, next example, or next piece. Same page, okay, so you don't have to write these down. But what these are saying is that if we have a limit as x goes to c of some function of x, f of x, and its limit is L, and we also have a limit as x goes to c of another function, the g of x, and it goes to k, then we can do a scalar multiple, meaning if I take some constant b times my function of x, and I take the limit as x goes to c, that's the same thing as that same constant being multiplied by what my limit would have been. Okay? And sum or difference works the same way. The limit of function f plus function g would be the same thing as the limit of the first function plus the second function. Or the limit of f minus the limit of g. The limit of f minus g is the same thing as the limit of f minus the limit of k. Limit of g, which is k. Okay, so you might find that it's easier if you've got some pretty nasty functions like a couple polynomials. You may find it's easier to find the limits first and then add those two answers together than it would be to add the polynomials, then take the limit. Does that make sense? Okay. Likewise, the quotient works the same way. If we're taking the limit as x goes to c of f of x divided by g of x, it's the same thing as if we had taken the limit of the first one and the limit of the second one and divided the two. So far, so good? Okay. And finally, a power rule says that if I have the limit as x goes to c of a function and I raise it to the nth power, that's the same thing as the limit raised to the nth power. Okay? So again, we're not copying these down, we're just looking at them. We know where to find them in the book, and if we feel like we need to copy them down to have our notes complete, we can do that. But here's how these work. So we want to find each limit. The first is the limit as x goes to 2 of x squared plus 5x plus 4. So what will we do? We could factor, or we could substitute the number in. Okay? They're going to be the same either way. Okay? So kicks and giggles, if we factored this would be the limit as x goes to 2 of x plus 4 and x plus 1, right? Okay? If I substituted 2 in, 6 times 3, 18. Okay? Now let's take it and use just the polynomial as it is. So the limit as x goes to 2 of x squared plus 5 times x plus 4. 2 squared is 5 times 2. So we're at 14 plus 4 more. 18 either way. Okay, so they're one and the same. The product, the limit of the products, the two functions multiplied, take the limit is the same as taking the limit of the individual functions and adding or multiplying together. Sorry. Okay, next one. So we already found this, right? This is the same thing as this was. So let's just put an 18 up here. And what's going to happen if we do the limit as x goes to 2 of x plus 4 in the denominator? It's going to be 6. And we get 3. So far, so good? All right, last one. Now we want the limit as x goes to pi of x times the cosine of x. So substituting pi in everywhere we see x. So we're taking pi times the cosine of pi. What is the cosine of pi? -1. So we're taking pi times a negative 1, and we'll get negative pi. Easy peasy? Yeah, this one's not bad. All right, and keep the factoring idea in mind for tomorrow. Okay? All right, so this is the assignment. Should be pretty quick.